Welcome to today's tutorial. So in this tutorial I'm going to show you how you find the critical numbers of any given function. Right, so if you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button and also the notification button. If you have any questions or you want to join my WhatsApp group, feel free to contact me on any of these lines on the screen. So we begin. Okay, we have the first question, which is says find, okay, we have f of x is equal to x to the power 3 minus 3x squared. Then we've been asked to find the critical numbers of this expression. So how do we find that? So we know to say at stationary point, any given function is equal to 0. I mean the gradient of that given function is equal to 0. So at stationary point, the gradient is equal to 0. So when you have, let's say for instance, a curve which is like this, at this point or at this point the gradient is a straight line, hence it's equal to 0. This side the gradient is greater than 0, this side the gradient is less than 0, there the gradient is greater than 0, but at these 2 points the gradient is equal to 0. So the gradient function is found by differentiating any given function. So when we have f of x, when we find f prime of x, this one is called the gradient function. So we're going to differentiate this. We're going to get 3x squared minus 6x. So when you differentiate this, this is what you're going to get. Then at stationary point, the this expression f prime of x is equal to 0. So you just put 0 this side, then you remain with 3x squared minus 6x. So to find the stationary points of this equation, you simply just factor out x this side. So when you factor out x, actually 3x is the one that is common. You're going to remain with x minus 2 in brackets, and then you equate this to 0. So either 3x is equal to 0 or x minus 2 is equal to 0. Hence the value of x here is equal to 0, and then the other value of x is equal to 2. So these are the two critical points that we have. Yeah, so these are the ones that you even use to determine the stationary point, if it's either maximum or minimum. So we're going to do that, I think, in the next question. So we can also do the same on this on g of x. So we can do the same on g of x. So g of x has been given to be x to the power 4 minus x to the power 2. So finding g prime of x gives us 4x to the power 3 minus 16x as the answer there. So we know that g prime of x will be 0 at the stationary point. So we equate that to x to the power 3 minus 16x. So we can factor out x, and we are going to remain, actually 4x is common, so we're going to remain with x squared minus 4 then is equal to 0. So this can also now be written as, let me just erase this part. Yeah, so this expression can be written as 4x open brackets. There we have x squared minus 2x, 2 squared. So we have something like this. Let me write it properly. So when you check this part, it's a difference of 2 squares, which can further be simplified to x minus 2 and x plus 2. Then you say this is equal to 0. So we're going to equate all the terms to 0. So even x minus 2, we equate it to 0. Even x plus 2, we equate it to 0. So this part will give us x is equal to 0. Then this other one will give us x is equal to 2. Then this one will give us x is equal to negative 2. So these are the three critical points that this function has at stationary point. Okay. So let's quickly look at another question. So the other question is this one. which is also straightforward. We have g of t is equal to t, then the square root of 4, the square root of 4, we have the square root of 4 minus t, which can also be written as t open brackets 4 minus t to the power 1 over 2. Okay, so now we can differentiate this one to find g prime of t, which is just going to be equal to using the product rule. We can differentiate this, so we can say 1 when you differentiate this part you get 1, and then you multiply it with that function, which is just the same as this function, which is the root of 4 minus t. Then you say plus finding the derivative of this. Okay, let me write t first, and then finding the derivative of this, we're going to have half, and then let me put square brackets. We're going to have half, then we're going to have negative 1 there. You can use chains rule to differentiate this part, then open brackets, we have 4 minus t to the power negative half. Okay, so we have this is the derivative of this expression. Let me just simplify it further. So we have 4 minus t there, then we have t over 2. This will be a negative because of that negative 1. So you have negative t over 2, then let me just say 2, and then the root of 4 minus t. Okay, so from there we can now simplify this expression. We're saying we're saying this part, g prime of t, when we're talking about critical points or at stationary points, is equal to 0. So what this means is that let me express this as a single fraction. So I'm going to have this times that. I'm going to get something like this. So I have a 0 this side, then I'm going to get 2 open brackets 4 minus t, then minus t this side, then everything over 2 root 4 minus t. So when we do the cross multiplication, this will get to 0. So we're just going to remain with something like 0 is equal to, and then this will be 2 times 4, that will give us 8, 2 times negative t, that will give us negative 2t, then minus t. So we are going to have something like this: 8 minus 3t is equal to 0. So the value of t at stationary point is simply just equal to the value of t is simply just going to be equal to 8 over 3. Yeah, so at stationary point we have t is equal to 8 over 3. Okay, so this is the critical point that we have. Alright, so you do the same with other questions. It's just a matter of just differentiating the question and then equating the solution to 0. That's all. Then the answers that you get are the ones that you are calling the critical points. Okay, let me try to get another question. So this one you differentiate it using chains rule, quotient rule, and then differentiating a trigonometric question is straightforward. If you need a video I explained that, you can contact me on WhatsApp. I'll send it to you. Differentiating all these trig functions, this is straightforward. So after differentiating a trig function and then you equate it to 0, it will give you an equation, and I'm sure you're supposed to get about 2 answers depending with the question, depending with how the question is asked. Sometimes you can even get 4 answers when you're dealing with trig equations. Alright, so thank you very much for watching today's tutorial. Let me solve another question from the same tutorial. My name is Amted. Shalom Shalom.